Alright, so in the last two videos we talked about transforming data with either addition and subtraction or multiplication and division. Now we're going to look at what happens when we do both at the same time. Okay, and again, this is something that's going to be practically useful, and there are a lot of real-world examples that you can use here. But I'm just going to go ahead and stick with the example that we used in the last video. So in the last video, we said suppose that. Let me just put a little dash mark here. So suppose that you sell t-shirts online. Okay, you sell t-shirts online, and you're going to look at the distribution of sales over the last 10 days. And I'm going to use the same distribution used in the previous video. Okay, so here's your distribution of sales over the last 10 days. I might use some different transformations here, but that's to be expected. And again, I want to see what happens here when I not only apply some sort of transformation with multiplication like we did in the last video, but what if I multiply and add? Well, what's a situation where I may have to multiply and add to a data set? Well, let's say, so you're selling your t-shirts online, right? And if any of you guys have sold anything online, you know every company that you want to sell with online, they want to take a small cut, right? Okay, so they want to take a cut of your sales. Now, let's say, just for convenience sake, you make $7 on every sale, okay? Then the online platform charges a flat fee of $2 per sale. Okay? Well, not per sale. Per day of sales. Okay? So every day, like let's just say every day you use the company, at the end of the day, however much you sold, they take $2 off your sales. Okay? So again, I know it's not like it's obviously not a maybe a business strategy that many online companies are going to employ, but just humor me for this one. This is more just to kind of demonstrate to you guys how exactly this would change things. So you make your profits each day, and at the end of the day, when you count up your profits, you have to put $2 aside to pay a flat fee to the online platform that you're using. Okay, so what does that mean? In essence, that means that I have this random variable x up here, right, which is the number of, and I guess a more appropriate term would just be like, this is how x is distributed, right? So you have this random variable x, and x represents the distribution of sales over the last 10 days. Now, I'm going to introduce a new random variable and call it t, okay? And t is just going to be the total profit. That's also going to be a random variable. Now, the way t is going to be distributed, okay, let me put a little tilde there. T is going to be distributed by taking x, right, the random variable x, the number of sales, multiplying x by your total profit, right? Okay, so you're going to multiply x by the total profit that you made on the day, and then what are you going to do to this transformation? Well, you're going to subtract 2 from every day's worth of sales. Okay, so t can be, and we're kind of leaking in a little bit to, I guess, linear transformations, which we'll go into more depth on as we move through these videos, but you can see that the way that addition and subtraction and multiplication and division affect this random variable x is they affect it in a linear manner, because you can see t is basically, and I should actually say t is equal to, right? This is a linear equation, right? You can model this transformation as a linear function, right? So t as a function of x is just 7 times x minus 2. And, well, we can go ahead and just, I'm going to do this very explicitly, okay? So t is distributed as, well, I'm going to take each variable, so 5 as the first variable. So I'm going to multiply it by 7 and then subtract 2. All right, and then I'm going to do 7 times 8 and subtract 2, so on and so forth, right? That's what I'm going to do to each random variable up here. So let me just go ahead and just write this out without expanding all of these, because I think you guys can kind of get the idea, right? So we have 33, 54, 54, okay, 61, 61, 68, 82, 82, 89, and 103. Okay, so here's your new data, and you can of course verify that all of these data points are just any of these random variables multiplied by 7 and then subtracted by 2. Well, how is this going to affect the distribution? Well, we should think about what we said in the previous videos, right? So we said that that addition and subtraction is going to affect mean and not mean and standard deviation, measures of center and location, right? So measures of center and location will be affected by the addition and subtraction that's going on here. Okay. However, standard deviation will not be affected by this addition or subtraction going on here. So the standard deviation is going to be resistant to this subtraction by 2 over here. Okay. And any measure of spread is going to be resistant to this subtraction by 2. However, measures of spread, such as standard deviation, IQR, range, they are going to be affected by this factor of multiplication. So this gives us a very interesting thing to think about here when we're thinking about our descriptive statistics for t. So essentially, what's going to happen is that the mean, okay, of t, the sample mean of t, okay, is going to be equal to, well, the sample mean of x over here, right, is going to be directed by or affected by both the multiplication and subtraction here, right? So we can say that the sample mean of t is going to be equal to 7 times the sample mean of x, right, minus 2, because measures of center, like the mean, right, the one that we're probably most concerned with, is going to be affected by both the multiplication and subtraction. All right. However, when we're looking at the standard deviation of t, okay, and keep in mind, if this is affecting mean in this way, that means it's going to affect any other measure of center or location in this way, aka median, Q1, etc. Right? So the standard deviation of t, well, the only aspect of this linear transformation that's going to affect the standard deviation is in fact this multiplication. So standard deviation, any other measure of spread, is going to be resistant to this subtraction going on here. So the standard deviation of t is just going to be 7 times the standard deviation of x. Okay? And so this actually, before I get into completing this this entire thing, what this actually does that's kind of interesting is that this gives us a general formula for how transformations work. Okay? How these transformations work. So if you're taking t to be a general transformation on a distribution x, okay, and t is equal to, well, we'll say b times x, because you may recall that b was the constant that we used for multiplication, right? We used b to denote a constant of multiplication that we're applying to a distribution, right? And then we add a, okay? This linear transformation, how is it going to affect the distribution of x? Well, the way that it's going to affect it is that we're going to have two related equations, okay, for the mean and standard deviation of x, right? So the mean, like the population mean of t, assuming that we have we know a true population mean of x. So the population mean of t is going to be equal to b times the population mean of x plus a. Okay, so the mean is going to be directly affected by this is just a general way of telling you that the mean of any distribution is going to be directly affected by both multiplication and division. Now, the standard deviation of t, okay, and I should use sigma, obviously. Sigma of t is going to be equal to b, and actually the absolute value of b, which is important to note, but again, we'll assume that for our purposes that b is always positive. So the absolute value of b times sigma of t, okay? And we will not factor in this constant of addition because we learned in the previous video that this constant of addition does not actually affect the standard deviation or any measure of spread for that matter. So let's say we just want to focus on these two very key measurements, right? So our data set up here, right? This data set over here, okay? I already have the mean and standard deviation for it. You can check it if you'd like, but I mean, we did it in the last video. So since this is a sample of 10 days of shirt sales, we'll call this X bar 1, okay? And that mean for the number of shirt sales, X bar 1 denoting the mean number of shirt sales, was 10.1. And then the standard deviation, the sample standard deviation for the number of shirt sales was 2.9231, okay? So now what's going to happen is I've applied this transformation here. How are we going to find X bar 2, which is essentially like the transformed sample mean when we multiply our profits by 7 and then subtract 2? Well, this is just going to equal, by this definition, it's going to be 7, the factor of multiplication that we're imposing, times the mean of the original distribution minus our constant of addition. So in essence, this is just going to be 70.7 minus 2. So our new mean is going to be 68.2. Okay? $68.2, of course. How are we going to find our new standard deviation? Okay? Well, our new standard deviation is going to be this value right here times 7. Okay? And that's it. Right? We're not going to factor in that subtraction because this subtraction by 2 does not affect the standard deviation. I know I sound like a broken record here, guys, but it's important, right? It's important to realize that addition and subtraction do not affect measures of spread. So you can simply multiply this value by 7, okay, and get the following value for the new standard deviation. All right, guys, so that's all I have for this video. If you guys found it helpful, please like, comment if you have any questions. I'd love to hear your guys' comments. And thank you for tuning in.